Hello, today I will solve IMO Shortlist 2018 Algebra first problem. I have given this problem at my contest during the TST for the IMO, but unfortunately I have misread the statement and instead of rational numbers I have read real numbers, and in this case the problem became impossible to solve, but finally I got several points because I have got almost complete solution, but the main mistake for me is that I was trying to solve for real numbers. And now we will see what was the problem. We need to find all functions such that fx squared times fy squared equals fx squared times fy. As in most of the cases in these problems, it is very useful to make left-hand side or right-hand side symmetric. And now, if we insert instead of x, f of x, and instead of y, then we can see that f of fx squared times fy squared equals f of fx squared times fy. And now we can see that left-hand side is symmetric for x and y, but the same thing can't be said for the right-hand side. So if we write f of y and x, here we get that from here we can get that f of y squared times f of x squared, this equals to the f of fy squared times f of x. Clearly we can conclude that because left hand sides are same, we can get that the right hand side must be also same. So fy over fx must be equal f of fy squared over f of fx squared. And now we can use this property to continue this process infinitely many times. If we write instead of y f of y and instead of x f of x, we get f of fy over f of fx, and this equals f of fy squared over f of fx squared. And if we look at the left hand side, if we take this to the square, we get fy over fx squared, fy over fx. So if we take this into square, f of fy over f of fx, this clearly equals fy over fx, but this also equals f of fy to the 4th power over f of x to the 4th power. Now we can get that if we fix y and x, fy over fx can be taken 4th power from this number also. If we continue this process inductively, we get that fy over fx equals to the f of ff, so on, k times f of x over f of ff. Like in a similar way, y, here we need y, over x times to the 2k minus 1 power and 2 to the k minus 1 power. So we can see that if some prime number p divides fy or fk, p to the k minus 1 also must divide this number. 2 to the k minus 1 must also divide this number. And because we can't take k as big as we can, as we want, this is impossible, because this number must be equal either 0 or none of the p's can divide this number. So If none of the p's divide this number, this means that fy over fx equals 1. And this means that the function must be constant. And if we know that function is constant, we can get back to our initial equation, and we get that c equals c squared times c. So the only answer would be c equals 1, because we know that c is positive rational number. Now if you check this answer, we will see that this works. Here are too many solutions, and the solution which I have written during the contest was to find what will be f of 1 over f1, and this number would be 1. And then after this, you need to multiply something to get that f of x squared equals fx squared. And you need to apply this infinitely many times in this process, and you get the 7 points. But unfortunately, as I have said, I misread the statement, and I got only partial results from this problem. If you will be interested about my solution, please write in the comments, and I will record another video about it.